Okay, today what I want to do, we're going to start in section 4.2. And what I want to do, I did a lot of teaching yesterday. We just went over some review on what was meant by the exterior angle theorem. Remember, the exterior angle of a triangle is equal to the sum of the two measures of the non-adjacent angles, or otherwise known as the two remote interior angles. We took notes on that yesterday. We talked about the sum of the angles of any triangle is equal to 180 degrees, and a corollary to that involves right triangles, where the two acute angles of a right triangle must equal to the sum of 90 degrees. If you're kind of fuzzy on that, you can go back to YouTube and re-listen to what we did yesterday in class. But let's put some of this stuff to work for us. Given this triangle up here, triangle ABC, this is the first example problem in your book. If I know the measures of two of the angles, given the fact that all three angles have to equal to 180 degrees, can I find the measure of angle C here? Now, how am I going to get that? Yeah, what I would do is add A and B, 85 plus 43 together, and that's going to produce, what, 128, I think? You know, catch me if I make a mistake here. Then take that and subtract it from 180. Then you're going to say 180 minus 128. And what is that going to produce? It's going to produce our angle C, isn't it? 52? Okay? Yeah, 52. So measure of angle C, therefore, is 52 degrees. Now, once you do something like this, let me encourage you, because it's easy to make a careless mistake here with some of these triangles. When you get that, for example, angle C here, what you should do is add all three up and make sure that they equal to 180 degrees, okay? Okay, now. All right, now given this second example problem in the book, okay? You're given triangle ABC, this vertical segment here from B down to point D. You don't need to know this right now, but it's called an altitude. You have two right triangles pictured here. All right? You've got triangle ABC, the bigger one, and this altitude is drawn from the vertex B down to this point D on segment AC. Forms basically two other right triangles, right? So you've got triangle ABD is also a right triangle. Now, suppose that measure of ABD, which is right in here, this angle right in here, measures 35 degrees, okay? It's 35 degrees. What would be the measure of angle DAB? And first of all, where is DAB? Where's DAB at? It's right here, right? Okay. Now, what would be the measure of angle DAB? Based on the corollary to the triangle angle sum theorem that says, the corollary that says in a right triangle the two acute angles are complementary, equal to 90 degrees, what must this angle A here equal to? 55, okay? Right, how do you get that? You're going to say 90 minus 35, okay? And that's where you get the 55 degrees, right, okay? Now that we know this, we need to find the measure of angle BCD. Now, how can we find that? So we know that this is a 55 degree angle. We're basically solving for the angle measures in this thing. What would be the measure of angle BCD? Oh, well, let's think about this. To get the measure of angle C here, or BCD, all right, this is an acute angle of the bigger triangle here. It's also an acute angle of the smaller right triangle, you know, right here, if I draw a little box in here, but we don't know enough about this triangle to say anything about it. You have to look to the big triangle here. Where this 55 degree angle here serves as one of the acute angles of this big right triangle, ABC. So if I say 90 minus 55, that's going to give me the measure of angle BCD. And what's 90 minus 55? 35. There's 35 degrees, isn't it?
Just switch them around.
Okay.
That's wrong.
90, I want you to think 90 minus 55. Switching does kind of work, but I don't want you thinking that way yet. 35 degrees. Now, even though this question doesn't ask for it, I want you to tell me this. Let's invent a choice C here. I want you to tell me what is the measure of angle DBC? What is the measure of angle DBC? It's my ugly B there. Okay, the measure of angle DBC is going to be what? What do we have to do to figure out DBC? Now we're thinking of the right triangle just on this side, okay? We're talking about right triangle BDC. Okay? Now, what is the measure of angle DBC? Angle DBC here. What is it? That's this one. I'm sorry, yeah, DBC. It's this one right here. That angle. What is it going to measure? If this is 35, you're going to say 90 minus 35. Okay? So it's equal to 90 minus 35, which again is going to be a 55-degree angle. Okay? Okay. So we know that that to be true. Okay. Now, given this problem right here, this one right here is using which theorem that we talked about yesterday? You should be thinking the exterior angle theorem. All right? So angle 1 is an exterior angle. All right? We know from the theorem that angle 1, the measure of angle 1, must equal to the sum of the two remote interior angles or the non-adjacent angles, the other two. The one it's not next to, the other two angles. So we're just going to call this the measure of angle A plus the measure of angle C. Okay? You can read that. Now, measure of angle A plus the measure of angle C. So if that's the case, what is going to be the measure of angle 1? How can we find the measure of angle 1? Let's substitute the values for those angle measures into the equation. So what do we do? Add A and C. So we're going to say 58, right? Plus 72. What is 58 plus 72?
130.
130? Right. So our answer here is 130 degrees, right? So that's how you generate an answer here using these theorems. So I'm assuming, therefore, you guys did a good job on your homework. Did all that seem straightforward enough? Who did your homework? Hands up all over the room for any parent that might be listening. Just a few not up. Okay. All right. Okay, what I want to do now is a few of these problems from your book, okay? You have to look at your book and see the diagrams. I'm just going to go ahead and put the math on the board, what you should be thinking to execute these problems correctly. Okay, I'm going to jump down to number 3, okay? Number 3, the directions are to find the value of x, okay? So on all these problems here. So you have, well, I'll just write it down. You got a triangle here. You've got one angle measures 70 degrees, and the other one over here, I should have drew this bigger, 49 degrees. That goes inside there. So you have to find out that angle measure right there. Okay? So what you do is add 70 plus 49, which is 119. Take 180, subtract that, and that's going to give you 61. Okay? 61 degrees. All right? On number 2, or 4 rather, this is the exterior angle theorem. You've got, I'm not going to draw it exactly, it looks something like this. You've got a 136 degree angle out here, 94 up here, okay? You're told X is over here, right? So what is this? We know the sum of the two remote interior, the non-adjacent, are equal to that exterior, right? So I know that 136 is going to be equal to 94 plus X. So subtract 94 from both sides. Okay? And what you're going to get, 136, now I use a calculator, don't do this in your head, okay? You're going to get X equals to 42 on this. That's how these work, okay? You see what I'm saying? So please use a calculator. This is not hard math to do, but it is easy to make a careless mistake on. Okay. All right, number 5. You have a right triangle here. X and 55. Okay. Now, how am I going to find X? We know that the sum of the two acute angles of a right triangle are complementary, 90 degrees. If you know the measure of one, how do you find the measure of the other? I mean, what is it? Well, the more direct way to do it, just consider these two angles. Don't worry about the whole triangle, because we already know this is 90 degrees, which means these two over here, the acutes can only equal to 90. So you need to be thinking of this. That's what you need to think in terms of. That's the best way. We'll do that. Let's change with a careless mistake. So subtract 55, and what's X equal to? 35. Yep. Okay.
Yes, you got that right.
Okay. Let's look at number 18 here. We have to solve for X here. To solve for X here, we have to find out what value of X is going to make this triangle true with the values given to us. We have to understand that all three angles equal to 180. If that's the case, you add all three of these up. Set it equal to 180 and solve for X. So what have we got? 2X plus X plus 2X plus 15. Okay? We need the values of X that will make this a true statement. All right? So what do? I do. And we're going to collect our X's over here too, right? How many X's am I going to have? 5. I'm going to have 5X. If I subtract 15 from both sides, then I get 165. Yeah, be careful. It would be easy to say 175, wouldn't it? Or maybe 155. It's going to be 165. Divide by 5. And what's it going to be equal to? What's X going to be equal to? So when I'm thinking about this, if I don't have access to a calculator, which I want you to have one, to try to figure out how many times will 5 go into 165, the first thing I do is I say to myself, how many times will 5 go into 100? It will go in 20 times. Then the next understandable chunk of information I can quickly plug into my head is how many times will 5 go into the next 50? 10. So 20 plus 10, now I'm up to 30. Now that leaves me with the remaining 15, which is 3, right? So that means, that's just how I think about it, how I break it up in my head to figure it out if I don't have a calculator, but I want you to have one. If you get to stuff like this, if you don't have a calculator, it's going to be, you see all the thinking we have to go through here? You're going to make a mistake sooner or later. I'll make them. Okay. All right, let's look at this one here, number 21. All right? This, I drew the diagram up on the board. What you have to do here is figure out what is X equal to and what is Y equal to. Okay? Now listen to me. We have to do a few things here to figure this out. Need your attention. To find out, we know that X and Y is going to be equal to what? Together. X plus Y will equal to how many degrees? Nope. 90. Because this triangle here is a right triangle. These are my cubes. So I know that X plus Y, whatever those measures are, got equal to 90. The problem is I don't know anything about either X or Y. I've got to figure out something about one or the other. And it looks like based on this diagram, I'm going to have a better chance of finding out something about X first. What I have to do is go into this first triangle over on this side of the diagram and look at it and try to solve for X in here. Then what I can do is use, once I find out what each one of the angle measures, this angle right here is equal to, when I find X, I can then use that that'll tell me what X is here, right? Then I can use that to figure out Y. So what I've got to do here first is I'm looking at the first triangle. It's not a right triangle because there's no box drawn in the corner. Even if it looks kind of that way, only go by what you're given. Now, if I what it looks like, so triangle ABE. We know that the sum of the triangles, the angles in this triangle is equal to 180. So we can say 50 plus 40 plus 2x plus 5 is equal to 180. Okay? Now, 50 and 40 is 90. 90 plus 5 is 95. So we've got 95 plus 2x. Now, what do I do? And what is that going to give me? 85. Yes, it is. Okay, the reason I stopped it is because I began to suspect I made a mistake, and I did. This angle is not 40 degrees, but 45. Okay? Now, that being the case, 50 plus 45 plus 5 is going to be equal to 100, right? It's going to be a little easier to figure out. Let's see where it's going now. Subtract 100 from both sides. Now 2x is equal to 180, and x is going to be equal to what? 40. What's x equal to? 180 divided by 2. Oh, you're right. Good. Thank you. I'm going too fast. You're right. You're right. Good. See? I'm going too fast. Teachers can make mistakes. Good catching. Okay? So we know x is 40. Now, I really didn't need to know that this was 55 degrees right in here. Thank y'all for giving it to me in the book. I didn't really need it. But I do need to know that this is 40 degrees. Because if it's 40, can I now figure out why? This means I've got 40 plus y is equal to 90, right? Yep. Y must be 50. That's a good test problem right there. A really good test problem.
Oh, then one.
Yep. X is 40, Y is 50.
40.
Okay, what I want your homework to be, among other things, I want you to go back to these 1 through 21, fix your mistakes. Now that we've gone into this section a little more and looked at the practical application of this information, I think you're going to be better equipped to handle that. I also want y'all to do this. On page, this is not a lot. What I want you to do is we'll review section 4.1. Want to make sure you stay up on that. Page 184. Page 184. I want you to do quiz 1, and that's just 6 problems today, okay? That's classification of triangles by angles and sides. So 1 through 6. And that is on top of that, of course, correct the mistakes that I believe are going to be there in your homework from last night. And we'll get into section 4.3 tomorrow, okay? But this should wrap up section 4.2.